So hi everyone, we are going to talk about the indexes in database. Okay, so what is index? Index is basically used to optimize our query. This is as simple as that. So what is that? So when we actually create a user table, like any type of table, not particular user table, we actually have a primary key and then the other fields. Okay, so first, when the database actually creates the table, it actually create an index on the ID field. We have seen that query actually on the find by. We have seen the query of find by ID. We get every time. So that's actually closer to. Suppose we are doing query on user table and we just analyze our query. We just see that we need to fetch the users using their email ID. Okay. What does mean that we want the sometimes we need to the email ID to get the username or the password or maybe any other details maybe that is not the context of this. Uh, so let us understand first how actually the query read happens on the disk and then we will go that how actually the index works and help us. Right? So suppose this is our disk and it actually has this called tracks. These are the these are called sectors and these actually blocks, right? So when you actually perform a query, it actually first fetches the whole block, then it actually sends this to memory, and then it actually takes the row you want. Okay, it actually takes the row you want. Okay. This is as simple as that. Now, just going forward, we all know that data is internally used B plus trees mostly. Sorry, this would be B plus trees. Okay. So B plus tree, let me just give you a structure. Suppose this is our root node. Okay. Then here we have internal nodes. Suppose these are the internal nodes. And then we have leaf nodes. Right? These are the leaf nodes. Okay. So actually in the leaf nodes, these are the leaf nodes. Okay. So suppose there have we have 100, then we have 120, maybe there would be 40, 60, 80, 100. And so this is 1 and 20. So there would be a rows written 1 from 1 written equal to 1. Then we have the 20, 25 so before that. And uh, this actually linked to this. Every block is linked to each other. Actually, this is linked list. Okay. So that's actually the B plus tree work. So when you actually just fire a query, suppose we want to know the index of the 11. Okay, so we want to know the ID 11. So it actually comes and see if it presents here or not. Yeah, it is present. Okay, so now this go to here and now it actually search there. It actually look for it and it actually found that the 11 lies in this block. So it actually go here and actually take the data of the row and just send to us. Okay, as simple as that. This is B plus tree. Okay, so now what index do? Index is basically create another B plus tree. Okay, but in that case, index actually index what is to index actually will create a B plus tree on the field email. Okay, so there we don't have ID, right? We have email like email one, like we have email, then here would have multiple emails, right? This block will say which email, the range of emails. Yeah, there that will be uh, yeah, and in the leaf node, so there is a cache. There is a cache in there. Uh, okay, so this is basically a B plus tree that there are a list of emails, uh, emails. all emails, these all are emails. So what happens in this leaf nodes? These leaf nodes actually don't store any data. Okay. So what happening in the ID is actually storing the data actually for our one, two, three. So in the case of ID, this actually stores the data, but in email, this actually don't store the raw data, right? So what it do, it actually stores the pointer to the ID. Okay, it actually holds the pointer to the ID that actually holding the data, actual data, right? So I think it is clear now. So that uh, suppose we want to email A, so it actually comes and see if the email A belongs to this range or not. Then it goes to the leaf node, and then just it just see the which pointer it which ID to it belongs to. So it just points to that ID, and it just go and fetch that ID. Okay, so that's all how it works. Okay, so now what is why this? Okay, so what happens is in the disk, actually when we want to fetch from here, it actually do a whole DB scan, right? So whole DB scan, then it just matches the constraints we give, and then from that it actually fetches that, right? Fetches our actual data. Okay, but in that case, for this, because if we search from this B plus tree, it has actually less time complexity than doing the whole DB scan. Okay, so basically the time complexity is for the it actually similar to log 8. Actually, this is the okay. So time complexity actually in the logarithmic in the V plus 3 time complexity is actually in the logarithmic basis. Okay. So so there is a new drawback in that. Actually, we can see like what the drawback we can see here. It actually increase memory in the space. I said it actually increases the space. Okay, so we can't every time just give all fields as the index. Okay, so it actually take extra space in our database, right? So we are seeing that if we create another index, it will create another p plus 3. Okay, so if we create this three, so these three index we actually give three as the index, so this will keep three more p plus 3 on that. Then we do the sort and all the operations. So this is actually we have to do the trade-offs that if we need it or not. So that's why we actually use the most frequent term. Okay, so we have to rightly choose which index, which things we have to do indexing and all. So I think that's all. And if you have any questions, you can just ping me and just comment. So I will be more than happy to answer your questions. And it is my actually first video. I don't know actually how is it going. So give me some feedback so that I can actually improve my videos. And thank you.